Welcome, geometry students. Today we're going to be learning about solving triangles using the law of sines, which is part of our target, which states solving triangles using law of sines and law of cosines. So today we're just going to focus on the law of sines. So we've heard the term sines before when we looked at our trig ratios. We learned about sine, cosine, and tangent. And we could use those to solve any right triangle. In other words, we could find an unknown angle or an unknown side length using the trig function sine, cosine, tangent. Well, the law of sines is similar. It uses those, but in a different fashion. It's actually a formula that we can use to find unknown side lengths or angles. So that's the same information we could find before using our regular trig functions. But the big difference is we can use this in any triangle. It doesn't have to be a right triangle. So this opens up some options for acute and obtuse triangles so that we can find unknown side lengths and angles for that. Now, I would not use the law of sines for right triangles simply because it's a little bit more involved, and we already have a lot of other resources we can use to solve right triangles. So this is primarily useful when using work with acute or obtuse triangles. However, it does also work with right triangles. We use this formula by matching up angles with their opposite sides. So in a minute I'm going to share the formula with you, and the big idea is the angles get matched up with the opposite sides. So if you take a look here for a moment, I'm going to draw a triangle off to the side, and I'm going to name it angle ABC. So when we talk about this formula, what we're going to find is the angles are always labeled with capital letters. So the three vertices are capitalized with ABC. If you look at the side length opposite of capital A, it's always going to be lowercase a, and again, it's across from the angle that matches up. So this would not be, for example, this would not be side length B because it's not across from angle B. So we want to leave that as side length A. Now the lowercase b should go across from angle B, and the lowercase c should go across from angle C. So when we look at it this way, our formula is going to be sine of angle A, remember capitals are always angles, over lowercase a, which is side length A, is equal to sine of angle B over side length B, is equal to sine of angle C over the side length of C. Keep in mind capital letters are angles. This would be something good to have in your notation, in your annotations, and lowercase letters are the side lengths. Alright, now this is what we call an extended proportion. It's extended because it has more than two ratios set equal to one another. When we're working with this formula, we're really only going to choose to use two of these at one time for our purposes. So we'll really just pick two of these. You might be wondering, well, which two do we use? And we'll talk about that in just a moment. Alright, so example 1 says to use the information in the diagram to determine how much closer you live to the music store than your friend does. So the key is we need to know how far I am from the music store, how far our friend is from the music store, and then compare those lengths. Well, here's the music shop. Here is my friend's home, and here is my home. So really we need to know how far our friend is from the music store. Well, we already know that A is 2.65 miles, and that represents our friend's distance from the music shop. What we don't know is how far we are from the music shop. So we need to find the length of B. Since we're finding the length of B, we should also consider labeling our angles. So for example, if this is lowercase b, the angle opposite or not touching that angle should be capital B. So that represents the location of our friend's home. And in this case, that angle is 65 degrees. Since this is side length A, the angle opposite or not touching that side length is angle A. So our home is at point A, and that is in this case 81 degrees. So our last vertex, the music shop, must be point C, and that's why the length across from that is 1.5 miles and is labeled as a lowercase c. So as you can notice, the angles opposite the side length have the same label, only one is capital, the angles are always capital, and the side length is always the lowercase. So since we want to know since we want to know side length B, we're going to need to use that in our proportion. So our formula that we just showed in the box up above in your notes has sine of A over A, sine of B over B, sine of C over C. I said we're only going to use 2 of those at a time. So I know that I want to have sine of B, meaning sine of angle B, over side length B into my formula. The reason being is I need to know and how to find lowercase b. So then I'm going to take my pick. I could actually use sine of A or sine of C in the next part of my proportion. So I'm just going to choose sine of A. We'll talk about that more in a few minutes and get into detail of why I chose that as opposed to the other. In this case, it actually did not matter. I could have chose to use sine of C over C as well. All right, so now let's input our information. Keep in mind you always want to start with your formula. So we have our formula listed, and now we're just going to fill in the information we know. Well, sine of angle B, we said angle B is where our friend's home is located, and that's a 65-degree angle. And across from that is side length B. That's what we want to know. So that's our unknown. And that's equal to the sine of A. Angle A is 81 degrees, so sine of 81 degrees over the side length opposite that angle, which is 2.65 miles. All right, so if we look at our proportion at this point, if we've chosen correctly, we should have one variable, and we do. In this case, the only variable we have is the lowercase b, or side length b. And if we had more than one variable somewhere else in our proportion, we'd have a problem. Then that means we probably did not choose our formula correctly. So we'd want to back up and start over with that. So since we have just one variable, we can continue on. By the way, sine is not a variable. That is an actual relationship that we have comparing our side lengths. So now we're going to go ahead and cross multiply to solve our proportion. So since b is diagonal from sine of 81, we're going to multiply b times the sine of 81 degrees. And we're going to set that product equal to the product of our other diagonal, which is 2.65 times the sine of 65 degrees. Now, what I would suggest doing is simplifying what we can in our equation. So, for example, the sine of 81, we can divide by that. Since b is being multiplied by the sine of 81, I can divide by that so that I can get b by itself. So I'm going to divide both sides by sine of 81 degrees. That cancels that out, and that gets my variable alone. Now, I could put this all into my calculator. I don't want to do that because it would be very easy to make a mistake inputting. So instead, I would simplify each part of our fraction. So the numerator, or 2.65 times the sine of 65, is going to simplify to be 2.4017. When we're working with the law of sines, we're going to go to 4 decimal places for more accuracy. So make sure you check that on your calculator to make sure that you're getting the same result when you input that into your calculator. Again, I'm just typing in what's in the numerator, 2.65 times sine of 65. Okay, now I'm going to find the sine of 81. So that is approximately 0.9877. So now that I have that, both of those simplified, rounded to 4 decimal places, I can do my division. So b is equal to about 2.4316 miles. Okay, so let's go back to our original question. How much closer do I live to the music store than my friend? Well, my friend lives 2.65 miles from the music store. And I just found that I live about 2.4316 miles from the music store. So if I subtract those lengths, I'm going to find that I live about 0.22 miles closer to the music store than my friend. So since this is a word problem, it's wise to write a description of what my answer means. So I live, let me try that again. I live 0.22 miles closer to the music store than my friend. So be careful. In the last quiz, we had some lost points because we didn't complete the question. So just make sure that you get in a habit of reading your question again to make sure you've answered all parts. We didn't just find B. We compared our length B to our length A so that we could really decide how much closer we lived. So now we have finished that and we've included units, so we're set. All right, example 2 did not provide us with a picture. So it says to solve the triangle. Well, just like before when we solved right triangles, when we solve a triangle, it really means to find all unknown side lengths and all unknown angles. So really what we have here is we need to find angle A, we need to find angle B. We already know angle C is 145 degrees. Now, in terms of side lengths, we don't know side length A, but we do know side length B is 7 units, and side length C is 33 units. So I have 3 unknowns that I need to deal with in order to solve this particular triangle. Now keep in mind, up until this point, all unit, we've been dealing with right triangles. This is not telling us that this is a right triangle. In fact, we know it's not because right triangles can't have an obtuse angle. So when I draw this, I'm going to start by labeling the angle as 145 degrees. And that angle is stated to be named angle C. Again, capitals tell us it's an angle as opposed to a side length. And then since I have an angle and a side length both with the same ladder, I know that that length of 33 must be opposite my 145 degree angle because the side length opposite that angle should have the same name but in lowercase. So if this is my angle B, then the side length opposite B should be the lowercase b, which is 7 units. Therefore, my last angle, since it's called triangle ABC, must be angle A, and I don't know side length A, so I'm going to just call that lowercase a, and that's going to be one of the quantities I need. So I need to find the length A, and angle B. All right, so don't write for just a moment. I'm going to show you a mistake, so don't write this part down. Okay, so let's say I pick from my first original equation in the box at the top of your notes. Let's say I just start with sine of angle A over side length A equals sine of angle B over side length B. Okay, again, don't write this. It is incorrect. I'll show you why in a minute. Okay, so I don't know angle A, so we're going to leave that as a variable. Sine of angle A. I don't know side length A, so I'm going to leave that a variable. Already I should be noticing a red flag. I have 2 different unknowns. I have angle A and I have side length A. I can't find those at the same time. So I'm going to stop and say, wait a second. Since I don't have either of those, that part of my proportion is not going to work. So instead, I'm going to choose to use sine of B over B is equal to sine of angle C over C. So the big idea is this. Once you pick your 2 parts of your original proportion, I'll remind you of what that was. It's up in the box on the front page of your notes. But if you pick wrong, you're going to have more than one variable. So stop, don't continue, and restart. Use another pair of proportions. Excuse me, pair of ratios in your proportions. So in this case, let's see if we're going to work out. So sine of C, now you can continue writing because this is accurate. I'm going to put angle C in as the 145 degrees that we were told angle C to be. Side length C, keep in mind, is opposite that angle, so 33 units. So far, I don't have any variables, so far I'm good. Sine of angle B. Well, we don't know angle B, so that's a variable, but we do know side length B. So if you look at this, we do have just one single variable. Now we're going to cross multiply. So 33 times sine of B, since those are diagonals, that product is set equal to 7 times sine of 145. So we're just cross multiplying our diagonals and setting those products equal. Now I want to get B by itself. So I need to start by getting sine of B by itself. So I'm going to divide by 33. Again, I would not approach this by doing all of it at one time in your calculator. I would instead simplify your numerator. So 7 times the sine of 145 is going to be, I'm going to put it up here so I have a little more room. Sine of angle B is 4.0150. And we're dividing that by 33. So go ahead and divide that. We should find that the sine of B is equal to 0.1217. Okay, so have we found angle B? Well, no, we have not. We have found the sine of angle B, but we still need to find angle B. So what we're going to do is we're going to do very similarly to how we worked with target 1.4, is we're simply going to switch these. So we're going to apply the sine inverse of 0.1217, and we're going to use that to find angle B. So the sine inverse of 0.1217 tells us that angle B is about 6.99 degrees. So now we have one of our unknowns. All right, well, the next piece of information that's quick to find is angle A. Since I know two of the three angles in my triangle, I can easily find the third. So we know that those three angles have to add to be 180 degrees. So if I subtract two angles I know from 180, I'm going to find that angle A is 28.01 degrees. Okay, so that tells us our three angles. The only unknown information I have now at this point is side length A. So we're going to go back. I'm just going to give myself a little bit more room. And we're going to choose which ratios to work with. Well, since we need to find side length A, I definitely need that in my information. So sine of A over lowercase a, side length A, and then I'm going to use sine of C. Now here, I could have gone and used sine of B over B. Reason being is I have all that information. Keep in mind, the only way that you can choose your ratio incorrectly is if you have more than one variable. So as long as in this next step, I have one. Okay, so I have the sine of A over A equals the sine of C over C. So as I was saying, this would be fine, or sine of A over A could equal sine of B over B. That would be fine as well. As long as I only have one variable as I put in my information, I'm okay. So the sine of, well, I know angle A to be 28.01 degrees. I don't know length A, and that's equal to the sine of C, angle C is 145 degrees, over side length C, which is 33. Now I'm going to cross multiply. So A times sine of 145 degrees is equal to 33 times the sine of 28.01. Well, I need to get A by itself. So I'm going to divide by the sine of 145. And I'll let you go ahead and work through this on your calculator. Again, simplify the numerator, then simplify the denominator, and then do your division. Go ahead and pause the video for a moment while you take care of that. Okay, well, you should have found that A is 27.02 units. If you didn't, please go back and try that. And if you still can't get it, let me know. We can talk about how to input that in on your calculator tomorrow. Now what I'd like you to do is try the You Try Nows. There are two problems below this, so to really have your notes complete by tomorrow, you will need to have those two problems done. If you find you can't get the correct answers, which are showed at the bottom of your notes, please bring that with and at least show me your attempts. But I do hope that you persevere through those and are able to find the correct answer, and then we'll move forward tomorrow. All right, well, thanks so much for joining me. Have a good day, and I will see you soon.